this one says P of t is the size of the population at time t. Which differential equation describes linear growth? So these are all dp, dt. So they're all the rates of change of the population. And if we have linear growth, then we're going to have a constant rate of growth. So that would be A. A is the only one that is constant there. All right, number 2, a rumor is spreading through a population of n people. So let me write that down. N is the total population of people. And it is spreading at a rate proportional to the product, so that's multiplication, of the number of people who have heard the rumor and the number of people who have not heard the rumor. So you're going to have your rate equals k times, and then the number of people who have heard it times the number of people that haven't heard it. So P is the number of people who have heard it. It's the number of people who have heard the rumor. Which of the following differential equations could be used to model the situation? Okay, so we're going to have dp dt equals, and then k is your constant out front to show that it's directly proportional. And then we want the number of people who have heard the rumor, so that would be P, and then times the number of people who haven't heard it. Now they didn't give us a variable for that, but if n is the total number of people and P is the people who have heard it, if you subtract those, that's going to give you the people that haven't heard it. And so that one is B. All right, so 3, the rate of change of the volume of water in a tank with respect to time is directly proportional to the square root of the volume. All right, so first of all, this can't be A or B because those aren't differential equations. They don't have a dv dt. So we want the one that says directly proportional to the square root of the volume. So you're going to have k times square root of v. So that one is E. All right, and then I think the rest of these are basically just solving differential equations. Remember, if there's no initial condition, that's the general solution. You just leave C in there, and that's an infinite number of answers. And then if you have an initial condition, you're finding one particular solution. So we're going to solve this one with this initial condition. So I'm going to multiply the dx over. And then we're going to do the antiderivatives. And if you want to put a 1 over here to remind yourself there's a 1 there, you can do that. And so this antiderivative would just be y, which is nice because that's your goal. You want y equals. And then we need an antiderivative for sine, which would be negative cosine. So this is -2 cosine of x plus c. And we're going to plug in pi for x and 1 for y. So it's going to be 1 equals. All right, cosine of pi would be -1 times -2 would just be 2. And so that is going to give us c equals -1. And so I'm going to go back to this step and rewrite it exactly, except put the -1 in for c. So -2 cosine of x minus 1. So that one is E. All right, 5. We're going to solve this differential equation with this initial condition, 2, -2. This one is basically going to be cross multiplication, or you could think of it as we're multiplying over the y and then multiplying over the dx. Either way, that's how it's going to separate. And then antiderivatives. So this side will be 1/2 y squared, and this side will be 2x squared plus c. And so we're going to plug in -2 for y. So -2 squared would be 4. Half of that is 2. And we're going to plug in 2 for x. So 2 squared would be 4 times 2 is 8 plus c. And so that gives us that c is -6. So we're going to just go back a step. I'm going to recopy this step exactly, except put in -6 for c. And then we're going to solve for y. So first I'm going to multiply over the 2. So distributing a 2 through there will give us 4x squared minus 12. And then we're going to square root. Now we have to decide whether we want the plus or minus, and this initial condition had a negative y value, so we want the negative. And so that one's going to be C, which you can narrow down from the other choices. But they do have this x greater than -3. That didn't really come into play because this was the only equation that matched what we got. But where they got that from is if you take this 4x squared minus 12 and set it bigger than 0, which it would have to be because you can't square root anything smaller than 0. If you solve that, you're going to get square root of 3. Oh, whoops, get rid of the squared there. So that's where that is coming from. Again, you didn't need that in order to pick your answer because we were able to still make that selection, but that's where that was coming from. All right, which is the solution to this differential equation? And then our initial condition is 3, -2. So this one again is going to be basically just cross multiplication. All right, so that's going to be 1/2 y squared equals 1/3 x cubed plus c. So we're going to plug in -2 for y. It's going to give us 2 over here. And 3 for x. 3 cubed would be 27. 1/3 of that would be 9. And so that's going to give us c is -7. So I'm going to recopy this step and just put in the -7 for c and then get y by itself. So we're going to multiply over the 2. So that'll be 2/3 x cubed minus 14. And then again, when we square root, we're going to have to decide if we want the positive or the negative. And this one again had a negative y value for its initial condition. So we want the negative square root. So that one is E. All right, so here we are going to divide over the y. So that'll be 1 over y dy, and then multiply over the dx. So secant squared of x dx. So on the left, we're going to get ln of y. And on the right, we need the antiderivative of secant squared, which would be tangent. Or if you want to think of it as the derivative of tangent is secant squared, we're just doing that backwards. All right, so then they give us y is 5 when x is 0. So if y is 5, we're going to get ln of 5. Tangent of 0 would just be 0, and then plus c. So ln of 5 is our c value. I'm going to recopy this step, except instead of c, I'm going to put ln of 5. And then we're trying to cancel out the ln. So you're taking e to the power of both sides to get that to cancel. And so we're going to have y equals. Now, remember this part we write out front just as a constant. The e and the ln are going to cancel. So my coefficient is 5. I'm sorry, not a constant. Coefficient is 5. And then e to the tangent of x. And when we get rid of the absolute value, again, we have to decide plus or minus, and our initial condition was positive here. So just 5e to the tangent of x. So that one is C. All right, for this one, we're going to divide over the y squared. I'm sorry, let me move this up. We're going to divide over the y squared. So it'll be y to the -2 dy equals, and then the only thing that stayed there was the 2, so 2 dx. So for this antiderivative, we're going to add 1 to the power, so that'll be -1, and then divide by a -1. So we're going to have a negative out front, and then this side would be 2x plus c. And I'm just going to fix this. I'm going to erase and just rewrite it. This would be -1 over y. All right, and then they gave us y is -1. So if we put a -1 here, negatives are going to cancel. That'll just be 1. and x is 1. So this will be 2 plus c. And so c is -3. Wait, I said those negatives canceled, didn't I? Wasn't y -1? I'm sorry, that should be a positive 1. I was going to say that felt wrong for a second. Sorry, y is -1. So those negatives are going to cancel. That'll be a positive 1. So c will be -1. There we go. All right, so I'm going to recopy this step, except put in the c value that we just found. And then essentially the y and everything on this side are just going to trade places, because we would multiply the y over and then we would divide all of this over. So they're just going to switch spots. And then I think they gave us another x value to plug in for this one. It says when x is 2, what is y? All right, so if we put in 2 for x here, this would be 4 minus 1 would be 3. So -1/3 is our y value. So that one is B. All right, number 9, to separate the variables, we're just going to multiply over the dx. And for this one, we're going to need to do a u substitution. So I'm going to let u equal cosine. So the derivative of that would be -sine of x dx. And I'm going to divide the negative to the other side. So the part that we get to substitute out is the sine of x dx. And in its place, we're going to put a negative and a du. So what's still there is cosine squared, which in this case would be u squared. And so doing the antiderivatives, we're going to get y equals -1/3 u cubed, which would be cosine cubed, and then plus c. And then I think they wanted us to plug, oh, here's the initial condition. Y is 0, so this is going to be 0 equals, and x is pi over 2. Cosine of pi over 2 would be 0, and then 0 cubed would still be 0, and times -1/3 would still be 0, so we get c is nothing. And so when I recopy this line, there just won't be a constant. Or I mean, I guess there is one, it's just nothing. So -1/3 cosine cubed of x. And then we want, what is the value of y when x is 0? So cosine of 0 would be 1, cubed would still be 1, and then times -1/3 would be -1/3. So if we plug in 0 for x, we're going to get -1/3. So that one would be B. And then last one, it says a curve has a slope of 2x plus 3. So that means my derivative is 2x plus 3. We want an equation with the initial condition 1, 2. So I'm going to multiply over the dx. And then do the antiderivative. So this would be y equals x squared plus 3x plus c. And we need to plug in 1 for x and 2 for y. So this would be 2 equals, and then if x is 1, this would be 1 plus 3, so 4 plus c. And so c is -2. And so I'm going to recopy this line and just put in -2 for c. So x squared plus 3x minus 2, so that one is d.